carry all this knowledge.
Also, anyway, talking about coffee, I always remember that one of our lecturers loved coffee so much. Every time we talk by him, he always tell us about coffee and interesting facts about it, like Robusta coffee and Arabica coffee. He always has interest about chemistry in coffee and try to make sensors to analyze it. The best thing, I always remember one quote from him. If you put sugar on your coffee, destroy its. Would you remember?
I remember what he said as without coffee, like a woman without inspiration, isn't it?
One more second. Everyone definitely to have a cup of coffee to have inspiration.
Really? It's only women?
I think we better to start our session and look at our competitors.
Well, we will debate later. Ladies and gentlemen, sorry for the interruptions. I hope you enjoy our chit chat. Now, it is my honor to welcome our moderator for today.
Please be invited to stay with a big applause. Dr. Rajan Surya. Dr. Rajan Surya PhD was the former vice rector in the period 2012 until 2019. 16, I'm sorry, and 2017 until 2021.
Mr. Zulfikar, I will hand over the session to you.
Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Second day of our conference today. Once again, I would like to thank to keynote speaker who already give space. That's Professor from Korea, Professor Oscar from Malaysia, and then today Dr. Farah Samreda. I visualize from spell your name, and then Professor Yuga and Professor Colette from Australia. And deeply appreciation for my colleagues from University of Brawijaya, University of Malang, University Mara, Malaysia, and also my colleagues from National Geographic University for your attendance and your participation. This morning, in the fourth session, we will discuss topic, interesting topic, but that's quite different from yesterday's class. It is focused on genetic engineering and biotechnology, especially for digital cellulose. And then also we discuss about sensor technology with Professor India. To save our time, I would like to remind again the rule of discussion for this session. That's 40 minutes for presentation and 10 minutes for question and answer session. Please welcome and join us, Dr. Perawat Samreda. Actually, we already talked together, discuss for soccer, because there's a flag we compete in soccer, but we are tightly, closely work together in research. Is that right? True.
let me introduce Dr. Ferawat just a little bit. Dr. Ferawat currently is working in National Center for Genetic Engineering and Technology in Thailand. That's supporting research stream, something like that. He has many papers in red and so many patents in the legal service. So he's really an expert and we are making have a good presentation from him. I think it is your part.
So thank you very much for this introduction. So today I'm going to give you the talk on my research, but the field really changed from yesterday. Right? Yesterday is more on let's say organic synthesis on the materials, right? But now we change the topics right on the utilization of resources from various types of agricultural ways using integrated chemical and biotechnology. Using integrated chemical and biotechnology. Okay, the next slide please. Okay, first thing I'm going to introduce you my research skills. Here is photo Thailand Science Park located in 14 minutes north from Bangkok. In Thailand Science Park, biotech is one of the 5 national research centers that we focus working on various types of biotechnology. Research group is called the biorefinery and bioproduct technology. So we work on translation of so we work on translation of the richness of agricultural products and biodiversity of microorganisms in Thailand to bioproducts of commercial interest. The laboratories under my responsibility have 5 laboratories that work on enzyme biocatalysts, cell factory, integrative biorefinery, biospecialties, and biocontrol agents. So you can see that application of microorganisms and chemical technology together. Okay, next slide please. Focusing on the theme that I'm going to talk today is on the conversion of renewable carbon resources to bioproducts. Right? So when they say something about renewable agricultural resource, so what does it mean? Right? So they can consider the first generation is the edible feedstock, edible raw materials, including the sugar from sugarcane, starch from cassava, and oil, let's say from the oil palm. Right? The second generation feedstock is the non-edible palm, that is the agricultural waste, mainly lignocellulosic waste, such as the sugarcane bagasse, cassava pulp, and various kind of palm waste. When we talk for the third generation, is focus on the use of carbon dioxide. That is the ideal substrate for eco conversion. This is also respond to the climate change issue as well. And also we can change the carbon dioxide to C1 intermediate, right? That can be used as a substrate for eco conversions. All of the first generation, second generation, third converted into various kind of biofuels, biochemicals, and various kind of biospecialties. And the step on conversion, the first step is the pretreatment fractionation for the lignocellulosic material to open up the structure ready for enzymatic conversion in the second step. For the second step, we will really develop the enzymes, do enzyme discovery from the genomes, do enzyme engineering, do the biocatalyst design for conversion of the pretreated product or fractionated biopolymers from the first step to sugar or other kind of intermediates. And the first step is the conversion of sugar into the final products, such as biofuels, biochemicals, and biomaterials. Thus, in this case, we use cell factory that is designed by synthetic biology for this kind of conversion. And all the products is used for various applications that we work closely with a stakeholder industry in Thailand in the field of biofuels and biorefineries, industrial and cosmetic, and also in agro processing and food content industry as well. Okay, next slide please. Okay, so what is the concept of biorefinery? Biorefinery is how to make use or to add value in agricultural products or agricultural waste. Many conventional industries, not only in Thailand, but not only in Indonesia, but also worldwide, want to transform themselves from conventional industry to biocomplex that transform biorefinery. Let's say for the agro processing industry, the sugarcane industry, the cassava processing industry, or the palm oil industry, they want to transform themselves not only producing cheap product, but also added value to their product, or adding extended portfolio to their product with higher value. And also the petrochemical and plastic companies, they want to change their raw material from fossil waste or petroleum to use agricultural waste or other bio-starting material as well. So as for sugarcane industry, right, the problem or the challenge for the sugarcane industry nowadays is that the people consume less sugar, right, due to the health concern. And in Thailand, we produce a lot of biofuels, bioethanol, biodiesel. But now, due to the coming of the electric vehicles, like the EV, the demand for biofuels is not going very fast like in the past. So they need to do something to extend their products. Such as for, in this case, for the sugarcane industry, now they use the sugar fraction for production of edible sugar and mainly sucrose. The molar fraction is mainly used for production of bioethanol that used for fuel. The gas fraction, that is the solid waste from sugarcane processing, is used mainly for the boiler for production of heat and electricity. But with the concept of refinery, the sugar industry is setting up biocomplex that can produce various end products. The sugar fraction can be used for production of functional sugar, not only sucrose, but production of, let's say, for other kind of high value sugar. The molasses fraction can be used for production of lactic acid. Lactic acid is converted to PLA, polyaldehyde glycol. Into different fractions biopolymer, including the cellulose fraction that can be used for used as the cellulose fiber itself for food packaging. The hemicellulose fraction can be used for production of oligosaccharides, and the liquid fraction can be used as the functional additive for various kinds of materials. These three products is really the topics that we will cover for today, and the next fraction such as for polyphenol from the wax from sugarcane leaf and again can be used for production of food supplement as well. This is how the biorefinery concept can make value to the sugarcane industry. Let's respond to the bioeconomy, circular economy, and green economy industry. That is the strategic national plan of Thailand, and also to the net zero carbon dioxide emission target. Okay, the next slide, please. Okay, back to the structure of lignocellulose. So what is lignocellulose? Lignocellose is a complex, right, of three biopolymers made together. First thing is the fiber of the cellulose, right? That is very high in crystallity, right? And it's very densely packed, right? It's very long fiber. The cellulose fraction is covered by the heavy cellulose that works as the network, right? The amorphous network that links the cellulose fraction to the liquid fraction. That is the polymer of aromatic compounds, right? That make this kind of lignocellulose different to the structure. And the lignocellulose is the basic structure of all the plant biomass, including the or the pattern as that you can imagine. This is the basic structure of the cell wall. So sugarcane gas, rice straw, palm waste, wood, chips, or other type of biomass is basically composed of the structure of the cellulose building. Okay, next one please. Okay. So the first technology of our laboratory is on the fractionation of the components of the cellulose. Let's say we work on various type of potent agricultural waste in Thailand, including the sugarcane gas, wood chip, palm waste, and food waste. We develop the green fractionation process that do not use any toxic chemicals. Basically, the technology that we use is by using subcritical water, water that operated at high temperature above 180 degrees Celsius under the pressurized condition. And also the often also process that use green solvents for the fractionation purpose. We have the facilities on fractionation of the biomass from the lab scale to the pre-pilot scale. Right? So get enough sample, send the sample to our industry. The cellulose fraction can be saccharified by using enzymes to produce cellulosic sugar, we call second generation sugar. And this cellulosic sugar can be further converted by microorganisms to various types of products. Or the cellulose fraction can be used directly as a fiber for production of packaging material or for production of cellulose composite material for various applications. The cellulose fraction can be converted using either chemical process based on liquid hot water, subcritical water to shorten the structure of cellulose into oligosaccharides, or by using enzymes for the same purpose and used as the prebiotic for food supplement called the cytooligosaccharides. The lifting fraction can be modified. Its structure, its solubility, its molecular weight, and its particle size, and used as the functional additive in various type products, including plastic, in polymers, and also in cosmetics. This is the concept of the fractionation. Okay, next slide, please. Okay. I would like to show you some examples of our published work. Right? This work is on the two-stage fractionation of sugarcane gas by using four tools. The first step is the hydrothermal subcritical water process. The second step is by the organophore process that use ethanol as the solvent. Okay, starting from the sugarcane gas, we use the subcritical water in the hydrothermal process to selectively hydrolyze and remove the heavy cellulose fraction out from the sugarcane gas. So we can run the process at approximately 180 degrees Celsius under pressurized condition at 10 bar with the pressure of nitrogen. So we can separate the cellulose fraction in the form of oligosaccharides. In the second fraction, we use ethanol as the solvent. So it can selectively extract the liquid fraction out, and the liquid that can again have the purity on 95%. That is very good in quality. And leave the cellulose in the solid phase, right? And the cellulose is also very enriched with, and the powder is also very enriched with the fraction of cellulose up to 8%. That's quite clear. You can see the effect of temperature. Right? We test the process at different temperature. The process at low phase, in this case, let's say at 140, 170 degrees Celsius, in the absence of any catalyst, that's water and ethanol in the first and second step. We can get the recovery of cellulose more than 80%. The cellulose, the recovery of heavy cellulose in the form of glycosaccharides and other type of composite sugar more than 60%. And more than 70% on the recovery of carbonic that was very well. And the process is upscaling into the pilot scale. Okay, the next slide please. Another example is the example that we do the fractionation process with sugarcane ash. That is the leaf and top of the sugarcane. In this work, we work closely together with the Research Center for Immunosphere in Kyoto University under the EHA project a few years ago. In this process, we use glycerol as the solvent. So why glycerol? Glycerol is safe. Glycerol is a byproduct from biodiesel industry, and we have big biodiesel industry in Thailand. And glycerol has very high melting point, so it has low rate of pressure. So even running the process at very high temperature at 180 degrees Celsius, glycerol still is a big effect, right? So the reactor that we need not to be pressurized, need not to chlorate to high pressure, and the process like by using glycerol as a solvent. We use PAC, that is the microwave accelerated process that can give direct vibration, with direct waving, direct heating to the water molecules, right? And give higher efficiency on catalysis of the reaction compared to conventional granulation. And we use alarm. That is a very simple chemical that usually in rural areas we use it as a formula to purify the water. And combine these three components together, we develop the process of fractionation of sugarcane trash, right? Starting from the first step on microwave assisted liquid hot water, subcritical water process to fractionate the zero fraction, and the solid fraction for the second step using alarm as a catalyst and using microwave accelerated visualization to separate the organelle salt with each other, stone washing, and obtain the cellulose fraction in very high quantity. So you can see that the purity of each fraction that we can obtain is at least less than 90%, and the yield is 60% to 80%, depending on the composition. Okay, next slide please. Okay. So now, go to the second platform technology that we have, that is on synthetic biology, on design the cell factory. Okay, again, we retrieve the biomass already, we fractionate the biomass already, we purify the biomass using the enzyme to get sugar already, right? So now, we want to convert the sugar or other type of intermediate from the biomass using cell factory. Okay. Basically, the field of synthetic biology is on the design of human organisms with the desirable, right, properties that we want. Let's say in this case, we do metabolic engineering on designing the pathway from production of the target compounds that we are interested to, and secondly, to extend the substrate range of the microorganism, so as for making to using withdrawal as the raw materials in addition to the use of sugar. And to second, thirdly, to increase the tolerance of the yeast of the microorganisms to prevent to inhibit or stress through the operation process. Such as in this case, to make it tolerate to inhibitors in biomass hydrolysis of the second generation sugar from agricultural waste. And we also use the machine learning process to design the cell factory that we work closely with Soetardjo University in Shanghai, China. They are experts in machine learning. Okay, so the target compound that we are working on is on the antioxidants. That will give you examples. Is on bioplastic monomer, that is lactic acid from the on fermentation or prevention of aromatase, and also for chemical precursor synthesis. Next one, please. Okay, this is the example on how synthetic biology works. Right? Okay, in this case, this is the work that we done focusing on the yeast, the very conventional yeast Saccharomyces cerevisiae, that is the yeast for production of alcoholic drink, very common yeast. Okay, so for Saccharomyces, right, so usually they produce ethanol as the major product. We want to engineer it by synthetic biology to produce isoprene, right? That in this case is like lycopene. That is the pigment in carrot, right? And beta-carotene, lycopene, that is the pigment in tomato, and beta-carotene, that is the pigment in carrot. You see the plate of microorganism on the top part, that is the Y type, is the natural strain of Saccharomyces. And after that, we engineer the pathway on the left side into this Saccharomyces by accumulating 9 genes in the that is homologous, right, in Saccharomyces, and do overexpression of another protein that's in green color. In altogether, it allows the production of biopigment in this in the Saccharomyces. For lycopene producing yeast, you can see the yeast has red color, the same color as the pigment in soil. For the beta-carotene, you can see the yeast has green intense orange color. That is the pigment in the carrot. Right? The process is now upscaled with a big sugar company in Thailand. Right? So you can compare that. Okay, on the graph on the right hand side, right? That the concentration or the yield per gram cell per gram direct of the cell, right? That we can obtain by the engineered yeast is 40 times higher compared to the extraction yield obtained from animals. Right? So this means that production of beta-carotene in the yeast would be very promising. Okay, next one please. Another example is on engineering of the yeast Saccharomyces again, right? For production of lactic acid, that is the monomer for bioplastic CMA. Thailand is now the second largest exporter of bioplastic to the world market. And so the company invests a lot on bioplastic. So what they do, what we have done is that, we first engineered yeast to produce the lactic acid first, right? By adding the lactic acid into the yeast. And later in this paper, what we have done is that we knock out the competitive pathway by knock out the gene encoding the enzyme that convert the intermediate for production of ethanol and the gene that convert the intermediate for production of ethanol. So in total, the concentration of the lactic acid that we obtain is remarkably higher. However, the thing is that this kind of yeast is not tolerated by to inhibitors in the cellulose any kind of food aromatic compounds. So we do conventional hybridization of the engineered yeast strain to the national type strain that is bring from our collection that has full tolerance to this kind of inhibitors. When you do hybridization, you can see the hybrid. Let's say in this case, hybrid number 2 work much better. So it can both produce the lactic acid at quite a good yield from cellulosic sugar, and also they can have full tolerance to inhibitor compound in the cellulosic sugars as well. Okay, next one please. Another example on the cell factory is that we do machine learning to design for the cell factory. So how to make the cell factory more efficient in production of the product that we created. In this case, we engineer the yeast Saccharomyces for higher production of ethanol at higher temperature. So usually Saccharomyces really produce ethanol really well at 30 degrees Celsius, right? But the industry, they want the Saccharomyces to produce ethanol better at higher temperature, such as in this case at 40 degrees Celsius. Why? Since in the ethanol production process in the big fermenter, right? Let's say in the fermenter with the scale of 100,000 liters, something like that, heat build up from metabolism of the microorganism, right? And you can imagine during the summer, the temperature, the outside temperature can be up to 40 degrees Celsius. So in order to save cost on cooling of the fermentation process, and if the yeast can produce ethanol at higher temperature, let's say at 35 to 40 degrees Celsius should be much better. So in this case, we work together with professor in Soetardjo University in China, right, to do machine learning to design the cell factory. So in brief, what we have done is that we do the design, build, test, learn cycle for synthetic biology. Firstly, we do the design, right? We do combination of combinatorial yeast by combine 5 promoters with different strengths with 3 genes. So in total, we will generate 216 combination of the construct in the yeast. Right? And then we test the performance of the 260 combination of the yeast and collect all the data on ethanol production, on production of byproducts, on the process, on kinetics, right? And use it as the data set for machine learning at 30 degrees Celsius. Based on the algorithm and the model that we generated at 30 degrees Celsius, we use it to select a limited set of these constructs at 40 degrees Celsius and do the learning process again. And then finally, we can predict for the base construct that can be used for production of ethanol very efficiently at 40 degrees Celsius. Okay, so next slide please. Okay. This is the data that we obtain when we try different models of machine learning algorithms. Right? In summary, right, we found that okay, the XGBoost model the XGBoost algorithm is the best model to fit all this data, and we can select the strength at 40 degrees Celsius that can produce 7.4% increase in ethanol compared to the starting strength. You may see that 7.4 is not a lot, right? But in industry, if it can increase 7.4% of ethanol production is a lot already, right? And will give much advantage to the production process. Okay, next slide please. Okay, we go to the second fraction, right? So we finished for the cellulose and cellulose sugar fraction already. We go for the second fraction that is on the use of the heavy cellulose fraction. Okay, in this case we work a lot on production of cellulose of different types of oligosaccharides. Different types of biologies or virtual ways have different structure of the heavy cellulose fraction. So can result in the production of different structure of oligosaccharides. If we started from sugarcane gas, we get the silo-oligosaccharide. If we started from palm we get the mannose-oligosaccharide. If we started from fruit waste, we can get the pectic oligosaccharide. These kind of oligosaccharides, they have very activity. They can be prebiotic, can be antioxidant agents, and can be bioactive with different kinds of activity. It can be used for animal feed supplement or for food supplement as well. So for the process, when we use this, first we fractionate the heavy cellulose fraction by using the process I mentioned already, by using the liquid hot water, the subcritical water process, and then do conversion using subcritical water or enzymes to reduce the burden rate from the polymer to the oligosaccharide. And to downstream processing, we can use the resin, and use the membrane, use SMB simulated moving bed chromatography, right, for the separation of the oligosaccharide, test the bioactivity of the oligosaccharide using the accumulation model. Okay, next slide please. Okay, focusing on the example that we give you today is on the enzyme engineering to make it as a good biocatalyst for conversion of heavy cellulose from sugarcane acid, the xylane, into cyclohexasaccharide. So basically, the enzyme, this type of enzyme called endocytolysis, work about 40 to 50 degrees Celsius. Right? But at this temperature, the solubility of xylane in water is not very high. So the concentration of the xylane that you can use as the raw material in the reaction is quite low. Right? So the productivity of the process is not very good. But if we can increase the thermophilicity of the enzyme to make the enzyme working at higher temperature, and at that higher temperature, the solubility of substrate can increase vastly. So this is the desirable process of the substrate. Okay, so what we have done is that, so firstly, we discover the acetylase enzyme that is relatively thermophilic, right? Works work well at 70 to 80 degrees Celsius from sugarcane gas methanogen from the agriculture source of gene discovery. And then we do random nucleogenesis, right, or we call by random mutation, right, and remove all the cyanide protein, right, to get the construct. Right. The activity the first construct work quite well at 80 degrees Celsius, right? And the conversion of oligosaccharide at 80 degrees Celsius can be reached up to 80% conversion. That is quite good. Okay, next slide please. However, this enzyme, right, its thermostability is not very good. Even though the working, the optimal working pressure is 80, but we need to have quite a lot of enzymes. So since it's denature quite quickly at the optimal temperature 80 degrees Celsius. So we want to increase its thermostability. So we do the rational design based on the crystal structure of this X11P, right, to do another 2-point mutation, specifically based on the structure to do it as X11P and Q. For the X11P and Q, the optimal temperature of the enzyme shifts from 80 to 85 degrees Celsius, and the thermostability of the enzyme consists of half-life. The half-life of the enzyme at 80 degrees Celsius is 66 minutes, right? And at 70 degrees Celsius is 14 hours. That is remarkably high compared to other type of cyanidase that's available. Right? And we test the mechanisms on the molecular dynamics and quantum simulation with the professor in Soetardjo and review the presence of hydrogen bonding network and high amine interaction. That is the determinant on this thermostability mechanisms of the enzyme. And this work will be published very soon. Okay, next one please. Okay. So lastly, on the most difficult fraction to be used, that is the liquid fraction. Again, what is liquid? Liquid is the big three-dimensional polymer of phenolic alcohol, right? Very complex, really strong, right? And very tough for degradation, right? Okay, so how to make use of it, right? So we first need to fractionate the liquid out from the brain mass, and then do factorization of liquid. The properties of the liquid, they have four basic properties. The first is that it has UV blocking properties. Second is that it has antioxidant and anti-free radical properties. Third is that it has antimicrobial properties and antibacterial, anti-fungi, anti-yeast, something like that. So can we give these antimicrobial properties to the material that we add in? And lastly, it has frame retardant property and linked into polymer if the polymer frame retardant. Okay, so we develop liquid as the additive, right? And add it in functional to get the functional plastic, right? We add the liquid into conventional plastic, including the polypropylene, polyethylene, and also anti-bacterial and liquid as the additive in bioplastic, in PLA, in PVS, in PCR, and also in Jember. And also we use this liquid as the active ingredient in cosmetic as well, and also use it as a dye in functional textile. Okay, next slide please. This is how we work. Starting from liquid is separated from different types of products, including sugarcane gas, which has difference in structure. Right? We have the method, right, to control, to customize, right, the properties of the liquid that we want based on its molecular weight, based on its particle size, from the nano range to the from the nanometer range to the micrometer range, or its solubility, whether it should be soluble in aqueous or it should be soluble in different components, so we can adjust, right? And also the color, right? We can adjust the color intensity of the liquid as well, right? And test on properties and use it for production of different kinds of products. Right? And the target community applications that we are working on is on the production resin, on production adhesive, on animal feed supplement, and on biophenolics for chemical industry. Okay, next slide please. Okay, this is an example of the prototype product that we developed and some has been, let's say, working with the industry. Right? Okay, so this is an example of the cosmetic ingredients that we developed prototype already. Right? Okay, for this one, we activate it as UV blocking agent and anti-free radical in cosmetic. Right? And this is developed the cosmetic as powder as lotion and now also a cosmetic company. The second application is as the UV application, right? In plastic, right? And we demonstrated in production of different type of plastic feed, right? And also in 3D printing filaments as well. And another example is on the eco fashion, right? That we use lifting as the functional line, right? In clothes, right? So in this case, this clothes has more UV blocking properties and also has antimicrobial properties as well, right? And also in other type of materials, in this case, for the rubber, right? That we can mix together and make the rubber has the properties of the liquid that we have. Okay, next slide please. Okay, so at that time, right, at the starting point, we do characterize liquid from different types of agricultural waste in Thailand very deeply, right, using 10 types of techniques, right, that you can see in very small font over there. The one that is published already, right, so we categorize the liquid from sugarcane agar, from sugarcane patch, from corn pop, and from three kinds of carbohydrates, including the palm fiber, and palm shell. Right? That is important agricultural waste in Thailand. And also the liquid from hardwood and softwood, right? From the eucalyptus wood and from the paralapa wood. And we characterize the liquid using different kinds of techniques. You see its molecular structure, you see its molecular weight, you see its availability of functional groups, something like that, right? And do suggestion of application of liquid for different application. Okay, next slide please. This is the detailed characterization of the liquid, right? We characterize the liquid using different techniques, including the FTIR, TGA, ATR, pyrolysis, GC, distribution of the monomers, right? And suggest that, okay, which kind of liquid from which biomass should be used for which kind of applications, including application resin, in oxidation stabilizer, carbon fiber, antimicrobial agent, and antioxidant. So we can identify, okay, that, okay, if we want to use it for this application. So what is the base biomass that we should start with? Okay, next slide please. Okay. In this example, right, we do modification of the liquid for use as the ingredient in cosmetic. Right? Maybe you can imagine it very easily. Right? Okay, so for the liquid, like in this case, we do molecular weight modification of the liquid using thermal catalytic process to use high temperature to break down the structure of liquid into smaller molecular weights. And it is, and we test for the properties of this depolymerized liquid for its antioxidant property and for its UV blocking properties. So here, so in this case, right, you can see that adding liquid into the base cream that we simulate the cosmetic, right, can keep increasing much better, right, UV blocking agent, UV blocking properties. Comparable and also for the radical scavenging activity, the antioxidant activity as well. That activity can give rise to this property as well. And we use for and we can decide whether addition of lignin to 5% can add the SPF value to the cream that you formulated from, let's say, from SPF 30 to SPF 100, right? But I think no one you use SPF 100, right? Maybe SPF 30 or 50, that use thinking about 1 to 3% is okay already. Okay, next slide please. Okay, this will be the last slide, right? This, the message that we want to convey today is that, okay,
So, 5 minutes.
Okay, so the message that we to give you today, the technical message is that, okay, I think not only Thailand, right, but also growing industry in Malaysia, in Indonesia as well need to transform somehow, right, to adding more value to the industry, right? From agro industry or basic biofuel industry, that production, that producing only methanol, biodiesel, to biocomplex, that production of biochemical materials, something like that, right? To add more value in response to the challenge in the near future, right? And when taking up biocomplex, not only one product is enough. They need to produce different kind of product, with high product from different fractions of the biomass, right? So this is why we work on different fractions of the agricultural waste. And by, and in order to do this, not only biotechnology is enough. We need to both biotechnology, chemical technology, and engineering together to go to the success, right? And if we can use the agricultural waste as the starting material, so in final, we can help somehow, right? Maybe not a lot, but we can contribute to the strategy of the world to go towards the zero carbon dioxide emission in the near future. Okay. Okay. Next slide, please. Okay. I think this is all my presentation. Thank you.
Very nice presentation. And it is our vision and session for to question, express your kind for question. Okay, Ibu Suryani, please.
Thank you very much. It is impressive during. Yeah. But I have two questions. Actually. The first is, do you really apply zero waste approach in your profession? And second one is, how about the carbon emission? Carbon emission.
How about emission?
Yeah, carbon emission problems because we are facing climate change at the moment. Thank you.
Okay, thank you very much for your question, right? Okay, so yes, for the in response to first question is yes, we do apply the zero waste concept for designing our process, right? But now cannot be zero, not be absolutely zero waste, but can be near zero waste. And I can say still some byproduct left that we do not know how to use it, right? But it's near zero waste. For the second question is that, okay, yes, we do evaluation of carbon emission of our process. Right? I give you one example. Right? Okay, in the EHM project that we work together with the Japanese group in Kyoto University. Right? So we analyze the LCA of our biorefinery process compared to the conventional process. Right? That, in Thailand in the past, right? So before they harvest the sugarcane, they need to do field burning, just burn the field, right? Before harvesting. That caused a lot of carbon dioxide emission. But now this process is starting to be banned by the government, right? And compared to the process of use the sugarcane touch directly for production of heat and electricity in the boiler, we show that okay, if we use our development integrated biorefinery process, the carbon emission should be decreased, right? Somehow, right? Compared to the, decrease a lot, right? Compared to the fuel burning, that is conventional practice, right? And also if we do adding, if we do, let's say, develop the technology to improve the yield or to develop the catalyst in some point, right, it can be competitive to the process for heat and electricity production in terms of profit. Right? So they see it in different aspects with our
Okay, so that's enough. Just one question.
Thank you. Very nice talk. I would like to ask you about, since you are talking about bio-based products and bio-based chemicals, it is well known that bio-based product, bio-based chemical is slightly expensive than the conventional ones. Could you please tell us about which product is competitive in terms of the price and how to tackle the problem? Thank you.
Okay, that is very nice question, right? So the answer is that there are, when we compare bio-based product to chemical product, right, we need to compare in different aspects, right? First, if it is exactly the same product, right? If it's exactly the same product, the price of the products that come from bio, according to the industry, they can add some, let's say, green green tag or something like that, right? To add the value of the bio, right, to the chemical route. Maybe the price can be up to 30% higher compared to the conventional one. Such as in this case for the production of ethanol, right? We do not do production of ethanol, right? But for the production, if you can produce methanol from bio route, the price can be higher compared to conventional methanol from petrochemical industry. And the thing is that the European countries now they are going to restrict the use of methanol, right, from fossil, right? So the companies in Thailand they need to find the source of methanol from bio. This is the first group of the product. And second group of the product is that product can be produced only by bio, right? Such as this case for the lactic acid, right? The lactic acid. If you produce lactic acid from chemical process, so usually you get D and L together, right, as the racemic mixture. But for the bio process, we can produce specifically L or D. Right? So in this case, the price can be set up, right? And according to the level that the market can accept. So there are different types of price incentive, right? The bio products have some advantage and also some challenge to the chemical products.
So that's why I work as a graduate. Thank you very much to Dr. Very nice speech and more important work. Thank you. Give big For the second keynote speaker today, we would like to invite Professor Julia Topa in this term. We got the Zoom meeting basic. Professor Juliardo would like to talk about the metal organic framework, based by the 4 point of care detection of infectious disease, biosensor. Professor Juliardo, welcome to our conference meeting, and it is your time to give a speech about the metal organic frame based biosensor for point of care detection of infection disease. Hello.
Bapak disamai.
Okay. Hello, good morning, everybody. Good morning. Can you hear my voice? Hello? Yes, yes. Okay. Can I start now? Hello. Can I start my presentation now?
Yes, you can start now, Mr.
Okay, thank you very much, everybody. So first of all, I want to thank to the Committee of Six International Conference on Chemistry and Natural Science, IC2MS, from University of Jember. It's my honor to be invited to this prestigious conference or meeting. Fortunately, I apologize cannot directly join this great event because I have some problem with my health. So it's very good for the community to provide video call for my presentation. So this morning I will give like one example of the framework based on for oil and gas of infectious diseases. So actually I belong to the advanced technology Indonesia. Of course, this was result from all my professional journey, including me, Muhammad Iqbal, kemudian setiap Asdilan and all efforts of my students. So, as we know in the term of life cycle consists of several parts, including substitution in the form of reaction with the target. And these conditions, they have really actual sensitive. So that is where nowadays tend to use the numbers of specific properties. And they have bioactive elements and the result of the transducer, of course, we amplifying and they will take some analysis and the noise reduction and many things they do by the control and finally display here. Display is the place where the user can see and read
measurement of the life cycle, and of course they will see not again depending on the carbon, for example, of the jet in the systems, so they will solve like how to do the manufacturing glucose, for example, there can be fire so among the nanomaterials used for the life cycle, there is materials in translation of this because the dynamic size of this area, is means the and also they have more materials can choose more channels. So we can increase the transportation of certain compounds with the whole. And after that, also the functionality vehicle means that this kind of functionality can be unified with various variables. We can add the profile, we can something like that to increase the chemical activity. And the other one that has cybernetic, to make the life of life, the biomedication, under extra. So this kind of force material, long force material, that is one kind force material. It is going to be metal and framework materials. As we stated before, the most heavy material one the active side. We can tune the flow, we can tune the surface chemistry. So by this, we hope that we can improve the performance of the sensing performance. And they can accept target more effectively, and they can show it with the noise because as we know that fire sensors were one of the big challenges for fire sensors is how we can experience with the huge amount of noise like other working. So, in our laboratory, we have developed several fundamental or within this we have PLC. PLC is actually something like installed in several house care units like polyclinic and education. So we developed two technology here. First is electrical and electrical sensors. So I there are other technologies so what we can provide, we want to describe how speed and detections. The most commonly is in T1 so that several different configuration of digital learning to control the size of the particles. And we got the control here, although there is still I feel that it could not be controlled, some of them can control. And we make variation here, and we see the score, we see the response of the document performance before we go to the object. And we can see that by changing the number one factor, we can see that the emission of T or yield the maximum or the optimum response. So after that, we use 20 as the best of variation experiments, and we try several repeatability chemical and she is the one And at the same time, like the league also kind of want to develop the implementation, the league implementation by ourselves. So we compare this is that is usually compare with which is by so we can see that almost exactly the same with our condition with the market provider. So then we continue by user to see the response when we have the antibody antibody and then we have the BSA. So the good one you can see here that when you have antibody, the common place as well as when you get the BSA, the common place, you can think that the microscope, the surface microscope in our sensor can remove the bonding in the antibody as well as the imaging. So here we then use our sensors to see the response with the various different amount, different concentration of the particular target. So we can see here we pick variation from 0.01 to 70, and you can see the results here. They increase significantly when we add the concentration of the hepatitis C, indicating the sensor can make so after that, we make linearity graph and got here the LOD, okay, the LOD of this limit of detection as well as 0.868 equivalent milliliter. I think this is quite low sensor indicating this can be used for detect the common sensor or common. And after that, we make the measurement in the other side. As we know, we measure this target in the blood, the comfort and stereo. And in our cell, of course, there are many different proteins, and including other types of hepatitis. So we with the ABCD, when we just using zero without the others type. It is clearly the sense of getting. I mean, the response higher, the highest one comes from the three Actually, all the capability is the highest. I think it's good to stay capabilities because there are only small capabilities that we see and the accuracy of not so good. So in terms of selectivity among the family of capabilities is not good. Okay, here and then we will make some measurement. We directly use the instruments we develop and we also see the system, the display here, start capabilities and then the measure and then we see the capability status is positive on it. And this is also the chip of the microphone here, and this is additional of the currently deposit on the surface of the chip of the experiments. And easily we can connect here to the software or server provide send the data to the center of the health center. So we also make some comparable using the data and show come from the synthetic service. So it is we can see here I think the set plans provided by the sensors indicating that the sensors still can measure in the foundation. So here also even we several blocks about example from 40% and some of them negative. So you can see that the person still can be sense of the person. So the next one we made also for the daily virus infections. So the same still MOM, but we use different type of the assessing type. One is for dengue virus. One dimensional PSC prepared by high amount of theater. The first one is more than but this one will be uh, modification level. So the theater level usually is functional group and the surface of S1. So you can see here the result for the theater level and the XRD factor of experience with the estimate of 20, 55, and 40, as well as we also able the same variation. So here also we can see that the combination of the SFT electrodes produce the best one. Okay, this one is 40. So that's why we continue to mention with other one. Okay, and then okay, this is the key one is the additional of antibody, the DSA, and also MS as the file. So we can see here clearly that we have several additional bioreceptor of antibodies and after that we can see that the countless situation we can see that the sensors can corresponding antibodies. And here we also measure several variations of and then we make the linearity, and from the linearity we can calculate the LRT unit of detection of sensors, which is about 0.962 milliliter with the 96% of linearity. And this is how we describe the step-by-step functionalization in the converter fabric. So the antibody personalized is then used as the center of the laser, and it's one of the 10 biomarkers. And then the sensing event was quantitatively observed for the change in the techniques we already described here in the A. So we continue the measurement and over the stability in the weak one, in the weak wise, see the increasing of carbon response will measure, but also the increasing still about 90%. And then we also deal with the other protein axis in the thoughts like urea, acid urine, uric acid, glucose, one see that the density is much higher compared to others, indicating that the spectrum can easily different between density and protein. So we also measure with the human cell to compare with the animal cell with the virus and we did the similarity of the difference between the static and the real blood is very small. We should measure even in in blood. So XPS is a form to analyze the presence of any group originated from protein. It is proof that the occurrence of any event of antibody on the surface of electrode as for the sensors. So in XPS provide and confirm that there is a link by antibody our surface of the material. So the next one, we also make other measurement. We want to see why people use the HSA to study what they have. So the amount of density on for prevent outside analysis for prevent, but you mentioned accuracy in water for 6 hours and technology and on four the information amount was accuracy one and for time size and here you can still in the 80. Then amount of accuracy has critical insights while a couple of letters and analysis. So we can see here we find the action we have some organization they change the facilitate pattern and we see how good the effect of the so we make the difference between amorphous and emission carbon dioxide. And you see the cycle for 3 from the 0.2 to 1.4. And we can see here that amorphous, as we are seeing, is like narrow. It's reached about 140, this carbon dioxide on layer reached from 8 to 9. So, amorphous has higher saturated properties compared to modified dioxide. And here, the radiation and versus temperature which are the ESA of amorphous and 5.5 and Q3 respectively indicating higher activity for a dioxide. And we make also photometry for 50 times to see how good instability by sensors with the scan rate at 50 millivolts per second. Amorphous accuracy is more stable than dioxide, which has a unique standard deviation of about 1.86. And here, when we add, so for amorphous SQST, and this is for dioxide, modified. So we can see here, although the previous one we provide blue, the amorphous is much higher in 60%, but in here, when we add the antibody and the DSA and the MS1 target, CT quite safe with amorphous and apoptosis. And we see here, and we see the variation from the 1 milligram to 100, for It's the same concentration in both amorphous and dioxide, and we still here. And both sample yields were used carbon decrease after immunization. Higher carbon had amorphous indicating an additional physical like measures like binding. And we calculated the liquid protections for both materials and limit of detection of AQAT and carbon dioxide are 1.64 and 2.07 respectively, indicating that amorphous one has more sensitive, slightly more sensitive, and better ability to detect and analyze very small parameters to modify. And here we see the sensitivity of the amorphous expression, and we also measure using human shell, real human shell. And maybe you can see this compared to the shell from the commercial. There is exactly saying there is no difference between human shell and the other the chemicals. So that's all about the technique and this third give presentation about the other optical sensors. So for the SPR surface transformation is quite interesting because they have high sensitivity for real time monitoring and kinetic analysis of such information. The last one of this is the very interesting that you can find in the so this is the simple description of the chip of the light sensor for SPR. We use glass substrate here and add microphonic input, and after that the biosensor from here and this is matrix and analytics track in the biosensor. So when we the light source integrated and the optical will catch the result. So there will be engine with more again in the ball surface and after the surface here. So this difference should be measured by plasma and in this case we can see the linear when we measure the so this is how we prepare MOIs for the GDC pattern. This is the alien chip, typical substrate for the response, and the particle surface of SPR sensor chip integrated with volume visual dioxide microclouds, sequential device properties that include in-chip variations and the position of volume visual dioxide and the surface function changes using antibody immunization and also activation by EDC and UASP and population. And then after that, the chip installation and sensing performance calculation. So we can generate and put the surface sensor see the changing of plastic phenomena and see the picture of how good the sensor. So the knowledge is of science formation. We see when we have here the absorb the relation mechanism by the strand, the absorb mechanism and creating each others, And by adding this one, we can measuring the particles of the growth. So we can control the micro from diameter to be at least from 1 to 2 micron, be 500%. And here is the dynamic response of CFP technical calculation versus delta RU. For where are you? This is the bare one A, and this is the after modification with the molybdenum dissolved job site. You can see that the landmark approximation of the model here is for modified by molybdenum sulfide oxide. You can see that the response time of the modified chip increased by 2.5% compared to their chip. I think this is quite on the result. And the CFP temporal certification versus the IU in bare chip have a linear correlation on the field. Can see both for bare and in modified chip, the plot following lung absorption is observed. It's quite different. This is lung field. Lung present, and this is the negative. So yeah, this is how we describe what happened in the cancer itself, and we see the stability is quite good stability compared to sorry, this is reproducibility. When you make several chips, the result is still consistent. And stability or selectivity, the other target for find negative change compared to the CFP TDT they provide. So another one will try zirconium MOS for COVID-19 detection. Same configuration actually developed from the AU called particle sphere. And so this is how we got the sample of the nanospectral slabs. And this is a lot of materials here. This is the sensor source. This is the light source of the lasers and photo detector to capture the changing lasers. And as you can see here is the bioreceptor. And see this is the response diagram. The IO66 as the MV functionalized chip is capable of distinguish samples from experimental labs, and then measure and calculate the changing the linearity here, and we got that the penalty reached down to 0.162 gram per milliliter. Or this is about 1.7 times 105 hours per liter, which is comparable to the daily practical diet tool for screening fast optimal patients. So I think this is still better, I mean, lower detection capability compared of the practical diet. Okay, I think this is very good. Very interesting for these results. COVID-19 fortunately just finalized this research when COVID-19 outbreak reduce the expectations. Yeah, we can try to implement the family. So now we also try for breast cancers using the function. The central has the LOD of 5.916, and then glucose also as well we can provide here. And in this case we try to separate us modified BC, and we got that the baseline is 28. So I think that's all my talk today's keynote speech. So can I say that I can summarize that the photonic will functionalize as chemical and biosensors, all the nature of the materials of abundant sites for biosensor utilization, and all of the frameworks to be decarbonized are proven to solve items involving unit complementary practices, daily manufacturing and system markers. The MI chemical substance understood as goals. So this MI has potential and opportunity to develop more and modification and modify the more and still we can carry out immediately with the biochemical senses. I think that's all my thought. Thank you very much. I take back to the moderator. Thank you.
Thank you very much, Prof. Sylvia, and it is time to start our discussion. That is basically and we give a chance for our audience to raise. Yeah. Thank you for the opportunity to ask. I'm very impressive presentation from Professor Yulianto, and I have only one question. As I understand it from your presentation, that you develop materials for Hong Kong, USD, USD, and then some special materials. For example, one of them is typical for modifying surface for the human detection, and the other thing is to modify the what's in USD by making it into upper focus and making it to upper hydroxide. My question is, how do you do the surface modification?
I'm sorry that the voice is not clear. Okay, it's better.
Clear?
Yes, it's better.
Thank you. I have a question about the modification that you made for the HAUXD materials. So you modify the surface by attaching the environment on the surface, and another method you also prepare the amorphous HAUXD, and as I remember, you also use it for hydroxide. My question is, what is the interactions actually between the deliver micro or something with the sensors? So you modify the surface as what you did, for example, by that data in our hydroxide. Is this the hydroxide groups or something that determines the sensitivity of the tensor? Thank you.
Okay, thank you very much for the questions. When we learn and when we talk about biosensors, and I think this is very good question, a big problem for us for biosensor research actually is how we can understand the sensor mechanism, because this is relatively technical to understand scale interactions. So that's why the previous also you, is there any assistance binding between receptor antibody and our particles, for example, something like that, using enzymes. But actually, we in our and for those when you use like sexual potency, hydroxide, and other iron, actually we first we want to make more active. So the method we have actually come from our study to the what kind of methods have a good interaction with the surface of target. Something like sensitivity is most kind of method already have a good sensitivity. When you see the taking virus, something like that. So that's why we see that the we use method should be added, should modify to the environment, beside the mental of the environment, like IC2MS, something like that. So the two methods, the three methods, or more methods, hopefully we make the more interaction quality with the antibodies like receptors. And the next one, of course, is the surface area. Because the surface area is very important when we can provide the surface area. Means that there will be more antibody can put the surface. Means that more antigen or more protein targeted diseases can be captured by antibody. So in the case we can make bigger changes in the color when we attract when we capture the target diseases. When measure it in the chemical, we can maintain the carbon. So the goal is actually how we can increase the two things, activity, and the third one is surface contact. Usually we measure the data, but it's something like transforming cows when we disturb the environment in other metals who have good athletic activity to the surface contact. Usually, the surface itself will disturb, means that the surface will increase. So, we should optimize between the two things. How we can increase the activity, at the same time, how we can keep the surface area of MOM still high. That's I think the two goals of our modification. And when we find type of technique of modification, actually, we see we refer to several records. The goals actually the two goals. Thank you very much. I can explain.
Okay. Any other questions? Okay, you have a question. Yes, the last one. Another question. That's similar. Have you ever tried consider about the material stability? Sometimes when I make some electromagnetic videos in jadi ada untuk sekarang so material yang durable atau change oh jadi that's not in the sense of or because you also only apply a small amount of current so you don't have this issue. Thank you.
Yes, yes. Yes, the second one is also good. Uh, Actually, the uh, when we make the commercial efforts at the end of the research opportunity, we will put we will these time resources actually let's say they are after use and exposed. So in terms of this one, actually because when we know the target, they already make a communication, so it's difficult to clean up again. So I mean, in terms of the stability of materials, I think we luckily we don't do not get more stability meters over using lines. But I think this is interesting. In our case, I think several nations with chemical we will not see the degradation significantly. But I will check that. Thank you very much. We are all nice and give applause for him. Okay. Okay, Mr. Simon, please.
We would like to say thank you for Dr. Ferraro Campbell and Professor Brian Liliaka for sharing incredible topics. We also thank to our professional guide, Mr. Soetardjo, Administration Well.
Now, we will continue with the next conversations in a few moments, but I will inform you, you're welcome to be while we prepare for the next section. And after that, please return to your seat to hear our next speaker. Thank you.
Kepada para partisipan bisa mengambil kopi dan desain sebagai menyiapkan untuk sesi selanjutnya dan dimohon untuk langsung kembali untuk mendengarkan materi dari speaker kita. Terima kasih. The third campus speaker will be moderated by Mr. Wahyu Prasetyo, PhD, from Institute 10 November. Please welcome to the stage Mr. Wahyu Prasetyo, PhD. Please give applause for Mr. Wahyu Prasetyo. Mr. Prasetyo is the chairman of Indonesia Chemical Society or HAPAI, is the conference private.
Mr. Wahyu Prasetyo Utama, Global Research.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. It is my pleasure to be a moderator of this keynote session. My name is Soetardjo, you present from the Department of Chemistry ITS. Before we start our presentation,
which will be held approximately 30 minutes, followed by 15 minutes of discussion. Let me briefly introduce Professor Spas of College. Professor Spas of College graduated from Sophia University, State Cleveland Overseas King in Bulgaria, and completed his PhD degree at the University of Technology and Economics Hungary. He is an honor professor of the chemistry School of Chemistry and the Department of Chemical Engineering of the University of Melbourne. Professor Pahas is also a fellow of the Australian Chemical Institute, which is the same as the Buran Kimia Indonesia in Asia. Most of his research is areas of analysis techniques, including paper-based fluids, chemical sensors, development of polymer evolution membrane for expressions or suppressing metallic particles, and the remediation and chemical mining. He has published 244 journal articles, 70 paper conference papers, 9 book chapters, and so of book entitled Advanced Physical Protection Analysis and Writing Techniques. In 2008, he has delivered over 60 invited keynote lectures in international conferences, which I believe that each conference will be the other 60 something for them. Your scholar is an editor-in-chief of Talanta and some other reputable papers or journals such as American Sensors, Environmental Modeling Assessment, and International Journal of Chemistry. He has several awards. Here, last one is one of the Master Honor Prize at Soetardjo University and the Environmental Chemistry 2017. That's all the brief and complete profile of Professor Sebastian for the Professor Ola. The time is short for generally 70 to 40 minutes. The time is short. Hello? Yes.
Thank you very much for this introduction, Mr. Chair. And I would like to start with my topic, which is entitled zinc separation based on the use of micropolymer techniques. Conventional separation methods used in chemical analysis often provide solid extraction involving various commercial extractants, and I'll give some examples of such extractants later. However, solid extraction processes have considerable environmental health concern because of the use of chemical compound solvents which can cause serious environmental and health problems. The industrial separation of the loss of solvents by dissolution in evaporators is a concern because it can increase substantially the cost of the separation process and cause environmental pollution. Membrane separation involving liquid membranes is an effective alternative to solvent extraction because it minimizes or completely eliminates the use of organic solvents, while at the same time it offers a high selectivity and flexibility in the original factors of conventional solvent extraction. In addition, the amount of extractants used is much smaller than conventional soil extraction applications, and this makes the use of expensive and highly selective extractants economically viable. Most of the extractants used are bactericidal properties, and the corresponding membrane are virtually viable, which is a big concern in most membrane-based separation processes. Polymer inclusion membranes, which are abbreviated as PIMS, resemble supportive membranes, which are arguably the most popular membranes in the first place. PIMS are relatively like themselves supporting membranes as far as their extraction and separation properties are concerned. In supporting technical membrane, the membrane is consistent with extracting and durable is retained in the pores, the high-porous membrane, while polymer inclusion membrane, the membrane interface, which consists of extracting in most cases, some pieces incorporate also a plasticizer or a modifier, is incorporated into the behavior polymer sheets. The extractant is only a vertical scale. In some cases, the incorporation of, as I mentioned earlier, plasticizer or modifier may be required to achieve homogeneity and sufficient flexibility of the membrane or to increase the solubility of the extractant species of the membrane interface. This time, I have given 3 examples of extractants, which are extractants also used in solvent extraction and plasticizers and modifiers. A typical beam is homogeneous and transparent, such as the beam shown in this photograph, which shows that there is no category based polymer. It's like a use based polymers and beams. You can see cellulose, glassate, and polyvinyl, such as polyvinyl materials. All these components based on very structure and plasticizers. The membrane is transparent and homogeneous. Also, industry has sufficient flexibility in chemical strength, so it can be self-supporting and the structure of the system today using the variety of some results and so far suggest a network of nanometer-sized channels which are built with the membrane interface. The small size of these channels is the fact that it needs to be a homogeneous microscopic level, and then the rate crossing the membrane interface is smaller supported membranes where the membrane is contained by the forces. And this technique is responsible for the role of beams, which makes it considerable interest in industrial specification. This is associated with the simplicity. We discussed the solution, based polymer extract and usually we use as a customer in classical position in that frame. And the membrane is filled up with that direction. So usually either urea or PVC and the Asian conveys beams, and microarray in the case of cellulose plastic. It's possible to custom line. This is schematic of a custom line. It's not made it's a great application that we use to grow in most cases. It uses behavior properties. The transport mechanism across the is called transport, which allows transport of carbon chemical species against its current concentration rate. This slide actually illustrates the first example of facilitated transport of an carbon across containing organic acid, ion exchange reaction takes place each. This is the ion exchange takes place each. And membrane solution interface, also is interface, exchange Y, and the receiving solution interface should be the left. And so the feed solution interface, the species is expected to be membrane, is very supposed to membrane, and it is stated that it's the other interface, where species should be strongly west. And the construction is very display, it uses very solution where there's another and translates into the recent solution. And as a result of this process, virtually all can be transferred across the membrane from the feed to the receiving solution. Against this apparent concentration rating, the negative value force of this process is the high hydrogen ion concentration. As you can see, this is rating of hydrogen ion concentration. We have these for a number of applications, which are in this slide, for the separation of metallic and non-metallic species of plastic and carbon interest. I'll talk more about this in the remaining in plastic segment, which is a technique that long-term in the environment for long periods where intersection rates the aquatic system, the internal solution where the features to be created over the prolonged period, and also the solution is related to the concentration of the aquatic system. We use also manufacturing particles, this is a coated with plastics. We have this beautiful extraction of sensors, and also database process where we have sensitivity. Also, all the separation, concentration, and formula systems, and I will describe how those systems our interest in using this for celebration dates back in 2009. Years ago, when we developed our first team for this separation, the extraction and separation using from aqueous solutions has become a bit and this classification is a dangerous substance. The waste is in solid waters. In this study, we normalized the which is abbreviated as this is a structural format, which is actually this is a very frequent use of the structure. The stock composition of the extracted disease adapters shown here, and actually the structure as the salt extraction. And following the solution composition of this extraction, which is 45% of that. So the source for the income institution was each change. All the base methodologies expect to be present in solutions require treatment with extracting analysis for its recovery are usually cobalt, copper, and nickel. Well, from soil extraction behavior versus only chemical extraction at page 3 and extraction this We eliminated line interference by specific investment. And this is this figure shows the constitutive extraction curves of this chemical. And as you can see, all the things is extracted because the concentration increases because it's extracted in the primary or other concentrations the results of the two transport study where the solution contains one order was it on one order these figures studies for that in the transport. So the membrane percentage in and this corresponds to concentration, which is transient concentration. Feed solution is transient concentration of resistance. And as you can see, one of the high concentration of gases, the transport was this membrane was also used to the old unsaturated formulation analysis system, and also the passive center, what I showed in this slide. And whole rejection analysis is a part of what they for automatic solution manipulation which is phenomenal or consumption, also can be used for the extraction of portable and random issues, such as or analysis and pictures in patients the coordination system shown here, the common membrane was also the extraction cell, which is the extraction cell. The single center is extended, those were injected in the injection plasma, and at the same time, the and then the central so last through the membrane extraction cells. The zinc was extracted from the pellet, which I showed you earlier, and then decided to get that complex across the membrane. And the two positive central solution will get accepted Jember the extraction cell. And now the computer rather stop the receptor was extracted, so it was utilized at this point by mixing with the so-called hydroxide reagent stream, so then other reagent was also was added in another reagent stream, mixed with the photo, and the orange color measurements of the analyzer this is the best center. The best center, I should mention before explaining the best center, that let's just for inorganic animals developed so far usually incorporate solvency phase, which undergoes all this process of determination of the amount of which involves the spirit of the animal from the solid. This can be seen in my the receiver phase is the solution phase that can be seen. Because this is the receiver phase can be directed and analyzed without good strictly analyzed. This is as I mentioned earlier, people feel separates the system from the solution. This is called as sometimes we use actually this is expressed somewhere there are certain challenges in using polymer materials for membranes, which are associated with their mass transfer emissions. This is mass transfer emissions is probably affected by the surface volume of these polymer starting materials. And the other challenge is the water stability, which depends on one kind of strength and other also good extractant. And the lower result is less feature extractant into basic spaces. And the rest of my talk about how we can get it to address the first challenge. I will not be one point which leads. I will create these microbeads. These beads are shown to provide other extraction when you still state that close to the passive elimination, resulting in significant higher specific in successfully for small scale separation and one or where how it works the industrial micrometers with an average pattern in the range of 0.5 unit per block. Therefore, we decided to develop micromethodology based on aspects of it's really to begin it's inside quite proof of concept by developing large mathematics and data and physical separations. And the microgrid system for manufacturing large microgrids by placing pressure to these opportunity was made we use two pumps, the peristaltic pump and one sewage pump. The peristaltic pump was used for the delivery of 20% solution, compound sulfuric acid, or the sewage pump was used for delivery actually microgrid solution, which in this case was a solution and this is connected to this is it's systematic flows. So you can see this systematic flow involves the distillation current. The distillation current is a sort of provide solution, but it's much more concentrated. Because the 20% sodium chloride solution is solid and while here we use much more sodium chloride in this distillation solution, well, actually, the distillation of this droplets. So, volume droplets initially rose upwards as a result of the present flow sodium chloride distillation solution. But this process was accompanied by distillation, which resulted in the formation of microgrids. This is just simple animation using close and this microgrids have higher than So the solution that they descended to the bottom of the glass bottom. And after separation from destination or remove moisture, constitute surface of this the effect of the base system physical and chemical parameters on fast first the concentration of the solution, which will correspond to the size. Usually 60% is not to be beyond the record, and because this status. Other parameters, is scale, type of restoration, solutions, restoration solution, the states in which you have and the states. The restoration will be the concentrations, the corresponding levels, and some corresponding flow rates. It illustrates the stages of the aperture, we selected the aperture. One component of between 60 and 70% were found to be almost showing this images. They were further the expression experiments were conducted is each immersive experiments. This might be the last class and they were essentially certain the concentration this figure here shows the construction curves for microbes between 50 and 70%. Deeper as expected, of course, because 70% deeper, they will go less than the beats. This figure here illustrates extraction curves for initial concentrations. Zinc and finally, the third figure illustrates the extraction curves for 70% of microbes and also extraction. As you can see, extraction curves, the back extraction curve, and as you can see, zinc was mostly reconstructed from the microbes, which actually shows the potential of these microbes for separation. The value of the usability of this microbe is the same catch. Microbes were conducted, so each must be 4 hours. And this figure compares the amount of zinc extracted per gram. Microbes which might go into this show that the illustrating stability of microbes. And of course, to test the practical capability of the microbes in separation of zinc from the solution of microbes were applied to the separation of the electrolytic solution containing and as I mentioned earlier, it appears to district is separated around the first participating in both. Efficiency and then the solution of the state. And this goes to extraction curve from copper, nickel, and zinc. It's known as equal to concentration in different copper and then this one more from this is the extraction curve. It's also used as a separation of and therefore we studied how this is used to perform complex operations. And this one shows the experiments, the concentration of chemicals this results were used for constructing the which are shown in this slide. This shows the direction of use of fluoride. Concentrations. And you can see if the zero concentration is the column can be used for 300 methods. In the fluoride of the dilution. So it can be expected, that if we extract a species can be diffused only within the surface layer. Now it is deeper, it means that stimulate. Therefore, we decided to develop further portion. The core is very easy, so not the shell contains and again we use PVC and the shell contains and this approach also reduces the amount of extractant used. Of course, in this case we have complicated shown in this slide, it was two solutions. So one provided against risk with managers. The other was useful delivery there is used whole products which is shown here in the core solution was found in the study solution, the shell solution was found in the results and solid products in the outer last. And then the history of the formation droplets, which contains core and shell, which were again introduced in the 5% of the chloride solution. The best is needed to prevent possibly in exactly the same way the roots were collected from all and processed in the same way as the next slide the size and shape on each and core solution concentration, also we needed otherwise this risk we can find and that's where the for 50% And this slide describes the optimal composition of Chelsea the course solution as I mentioned earlier. It's the most the delivery solution. It also provide because of the flow rate solution affects the size of the it's results when the flow rate solution at present, we're not construction of that to this portion line. It's not for the construction. And finally, the next is also included that material or concentration and species analysis. This focused research in my talk was conducted across exploration and research. How my contribution is I'm now for your attention and especially to your master.
Thank you, Professor, for your inspiring and comprehensive talk about the membrane and its application for the field area. Is there any question from the board? While waiting for the question, I only have answered. Memory is quite interesting for me because I work for a while, but still really in this area. The interesting part for me, so the mechanism to separate still ions from the field to the area is not by the or procedure sometimes, but because of the interaction between the ions, between the extract molecule is included forever. And the second question is, there is a good example from your work that your materials or your minerals spare zinc oxide cannot zinc plus, but it cannot spare iron because the curve of the concentration is still the same a lot of the time. How can we choose? How can we choose the selectivity of the membrane to be sensitive only for one metal ion instead of other isomorphic ion?
Okay, thank you. Now, let's start with your second question. Actually, as I mentioned earlier, separation is basically an original conventional solid construction. So, we use knowledge to accumulate solid construction to think out well and extract which is selected for a particular ion, whether it's a cation or an anion, it doesn't matter. There's so many such structures available in solid construction, and it's essential anyway choosing the structures. Because use the knowledge already accumulated in solid construction. And also, of course, I've got some but basically, instructions are based on the basis of so structural research. Please just remind the first question the question also looks like here the last part of the question.
Yeah. So I think your first answers indirectly answered my second question before you mentioned that the point of we definitely understand the point of this version is by choosing the correct open oil substance to be put in the membrane systems so that the substance can be safely interact with the specific area. Am I correct?
Yes, that is
Thank you very much. Is there any question on the floor? Yes, there is a question. Thank you. Please, Professor.
Hi, Esperance. Thank you for your nice presentation. The new one. In terms of the analysis calculation, which one is better P, P in this case? A is the polymer concentration. Which one is, or maybe you have already did in what is the polymer.
Yeah, well, that's an excellent question. It is not easy to answer. It's not easy because there are several advantages using peaks. I'm not saying that mathematics are bad. They have their use, particularly for engineering processes. One of the years ago, so, on the application, if you're speech separation or a reference volume, then 100% choose both separation is. But if let's say, let's say,
nggak bisa dipindah nanti. Mau dipakai untuk satu pembicaraan nanti pas paralel kan dia dari kamera ke si pesertanya. Bisa nggak ini dipakai? Jadi nanti pasang zoom, hasilnya ini nyolok ke laptop aja. Bisa kan ya? Bisa kan? Jadi kan cuman apa ini USB.
Gitu loh.
Ya, bukan, cuma satu kameranya aja. Ini dicolok di laptopnya. Bisa ya? Jam 14.45 ya, sesi 2 ya. Habis kopi break lah, jam asar. Ya, nanti pindah ke sana. Setelah itu nanti pasang lagi di sini untuk porsi. Ya, oke. Thanks ya.
Remember that in the end of our session, in the development for the audiences and value as a presenter,
Thank you.
Okay. Actually, you already
Yes, yes. Okay, well, for the rest of the conference, looking forward to catching up in person. Yeah.
See you.
For the next agenda, we have a postal session. Usually will be held in the room behind the desk in front of the gate. There are many posters which are already attached, and there's also a poster presented by Jember National University for the participants in the competition. You must have a poster about the company and untuk agenda selanjutnya akan ada nanti poster yang akan diadakan di sorry, I would like to invite Dr. Ferawat Breda and Mr. Soetardjo to speak to receive the software and certificate as our appreciation and thanks.
I would like to invite Mr. Reza to give the certificate and the souvenir.
Let's give them a round of applause. I will announce once again for the next agenda, we have a poster session. This session will be held in the room behind the desk or in front of the gate. There are many posters which already attached there, and there's also a poster presented by Jember National University. For the participants to join the competition, you may stand beside your poster because we will come and ask for your poster one by one. Jadi untuk selanjutnya ada baca poster dan bisa berada di belakang Anda di depan ini. Dan untuk bagi para partisipan yang perlu dalam poster ini atau tugas dimohon untuk berada di sini poster Anda atau tidak akan datang dan melakukan tentang poster Anda.
And for all the other fans who interested in embracing our posters, you can go ahead to the poster room, and you also can read the posters with a scan QR code inside of the poster room. And at the end, you will give a door prize for the lucky guest. So if you're not lucky, please stay tuned with us. Thank you.
Baik untuk para tamu
Ini kan tempatnya ini. Saya
masalah
geser
yang
geser deh.
hadir pada hari ini juga dapat melihat sesi poster di belakang dan terdapat QR barcode yang bisa di-scan untuk menilai manakah yang terbaik untuk Anda serta nanti akan ada surprise bagi peserta yang beruntung. Sekian dan terima kasih.
Baru disilasi belum jauh nyampe lah yo udah siap semua alasannya sudah ada udah bilang udah bilang emang kesepakatannya ngobrolnya jam setengah tiga insya Allah kan ujiannya baru kasih pembahasannya banyak sih kemarin soalnya data perhitungan udah beres kita sih proses nyusul udah bilang Lagian pagi-pagi udah di stay sini sama bapak ya. Iya. Yes,